So here's the answer to yesterday's TikTok question. Take an 8.5 by 11 piece of paper and start to cut out squares from the four corners. All the squares are congruent, and fold up the flaps. How deep of a cut should that be in order to create a box with the greatest possible volume? Well, we can solve this algebraically quite simply if we decide to call the depth of cut x. I'll put an x here, that's an x by x square. We'll put one over here, and we'll put one right over here, as shown there. So now, if it's 8.5 by 11, well, this width of 11, and that's x and x, well, this should be 11 minus 2x. And if it's 8.5 this way, that should be 8.5 minus 2x, that piece, like that little chunk right there. And when I fold this up, look at that. I have a box now whose width is 8.5 minus 2x, the length is 11 minus 2x, and the height of that box is actually the depth of the cut, which is x. So, looking at it this way, I can actually multiply the length and the width and the height to create the volume function right there. So whether you use calculus to get that maximum value we need to find like right up here at the tippity top, or whether you just look at it algebraically, writing the function and graphing it and seeing what the max is, you can do it a bunch of different ways, but it actually turns out that it's somewhere, that magic depth of cut should be roughly, I think, 1 59/100. That is the maximum of the function, and the volume of that box is roughly 66 1500 cubic units.